Hello viewers, welcome back to another section of my multivariable calculus tutorial. In this video, we're going to solve a triple integral in spherical coordinates problem. In this particular problem, we have the boundary portion given as a sphere and also as a plane. We've solved different forms of this problem in our previous video, and if this is your first time visiting this channel, kindly subscribe, you like, and also you get access to our previous videos. Kindly watch this video to the end so that you understand every portion of the video. So it said evaluate the triple integral of x squared plus y squared dv, where this it said is a region portion of x squared plus y squared plus z squared is equal to 4, where y is greater than or equal to 0. Okay, so you realize that given this particular integral, you can't integrate this with respect to x, neither with respect to y, because there is no term here that's going to allow you to cancel out. For that reason, we only have an option of converting this to the spherical coordinate. So how do we do that? How do we convert this to the spherical coordinate? To convert it to spherical coordinates, we are interested in parameters such as rho, which is the radius of our sphere, then theta, then also phi. These are the three parameters we are interested in. So if you're able to find the limit for this, then we are good to go. Now, we are supposed to draw or sketch this region for us to see how it's going to behave and for a clear and better understanding for our various limits. So let's draw some x, y, z plane. So I have my x here, my z, and also my y at this point. So realize that if you are supposed to draw this from the quadratic surfaces, x squared plus y squared plus z squared is equal to 4. This is the equation of a sphere. So since this is a sphere, you realize from the conversion of Cartesian to the spherical, this whole thing is going to give us x squared plus y squared plus z squared is equal to rho squared. Therefore, rho squared is going to give us what? 4. Therefore, our rho is equal to 2. Rho is a distance, so we are not interested in the negative value. So rho is equal to 2. Now, the next condition was y is greater than or equal to 0, meaning that we are interested in the positive parts of this region, the positive part of what? This region. So let's see how you're going to sketch this. So considering the positive side of this region, and this is a sphere, so straight away I'm going to draw the xy plane here. So this is the x and this is the y. So we are interested in this part of the graph, So I have my negative y and negative x. So you're saying that y is greater than or equal to 0. So meaning our sphere, this sphere which is of radius 2, so from here to here should be what? 2. The radius is 2. Should span just here. So you are going to have it here like this. So you have the sphere just spanning here. That is it, around this place. It's spanning around this place. And it's having a radius that is 2. The rho is 2. So it's spanning around here. From this, we can say that the limit point for the rho is 0 less than or equal to rho, and less than or equal to what? 2. Now, we come back to theta. From our previous video, we realized that we had our region at the left side here, and then we got from pi on 2 to 3 pi on 2. Now I realize that if I'm to start from this positive x-axis, I'm going to start from just here, is just starting from this side towards this through up to this. So this is simply going to give us an interval from 0 to what? Pi. 0 to pi. we are going to move through 180, but we are beginning from the first quadrant. So once you get this, you move to phi. Then phi, which is also the radius, is spanning around just in this 180 direction. So it's spanning around this way. So we're going to have phi to be greater than or equal to 0, but less than or equal to what? Pi. Now let's see something. In spherical regions, if you get a quarter region, our phi becomes, when you get a quarter, yes, then we can get a quarter, you can get also this way. So when you get a quarter, phi become greater than 0 but less than or equal to pi on 4. Then when you get a full hemisphere, you get your phi to be greater than 0 but less than what? Pi on 2 in that direction. But here lies the case, we are moving around this way. So it's going to be spanning here like that. So it's 0 to what? Pi. So let's see. I'm going to have my integral. The outer is going to take the phi. So 0 to pi. Come again, 0 to pi. Then 0 to 2. Then you have to convert the x squared and the y squared. So x squared, you know x in the Cartesian is equal to rho sine phi cos theta. Then y is equal to rho sine phi cos theta, sine theta. Refer to your formulas, then you come back to do this. So you're going to have open brackets rho sine phi cos theta all squared plus rho sine phi sine theta all squared. Then we have rho squared sine phi, then the rho, the theta, then finally the phi. So once you have this, we still further simplify this. Then I'm going to have my 0 pi, 0 pi, 0 to 2. I'll get rho squared sine squared phi cos squared theta plus rho squared sine squared phi plus sine squared theta, all multiplying rho squared sine phi, the rho, the theta, the phi. At this point, you realize that we have cos squared, we have what? Sine squared. Then I have this here, so I'll factorize rho squared sine squared phi out. I'll get cos squared theta plus sine squared theta. Then multiplying rho squared sine phi, the rho, the theta, the phi. So after getting this, I can say that this is equal to 1. So rho will give me rho to the power 4 sine cube phi, the rho, the theta, the phi. My integral comes 0 to 0 pi 0 pi, like this. So once I have this, I'll further simplify. Then you know I'm going to integrate the rho first. So I'm going to get rho to the power 5 over 5 sine cube of phi. Then I introduce 0 to 2, the theta, the phi, nicely here. So at this point, I'm going to put 2 here because 0 here will make everything 0. So 2 to this here, I'm going to get 32 over 5, like this, sine cube phi, the theta, the rho, the phi. And here, the next thing is to integrate with respect to theta. So here, since we don't have any theta term, we assume that we have S1. So when you integrate with respect to theta, you get theta back again. So I'm expecting 32 over 5 theta sine cube phi, then 0 to pi here. That is for the theta. So that when I put a pi inside, I'll get 32 over 5 pi, then sine cube phi, the what? Phi, then 0 to pi. So now I'm left with integrating with respect to phi alone. with respect to phi alone. I have a sine cube here. We can't integrate this straight away. We need to break it down using the trigonometric ratios and identities. So sine cube, we know that sine cube is the same as sine squared multiplying what? Sine theta. So let's say sine theta multiplying sine theta, sine squared. Then, so let's see, I'll put a 32 over 5 pi somewhere. Then I'm going to have my sine squared phi multiplying sine phi. And you know that sine squared is same as 1 minus cos squared. So I come again 1 minus cos squared phi multiplying what? Sine what? Phi. I can then expand this so that I get sine phi minus sine phi cos squared phi, like this, 32 over 5 pi. So once I get this, I can split this into two separate integrals. That is where this one, I will integrate this separately, then I will integrate this one too separately. I'll push this out, so 32 over 5 out, over 5 pi here, out. Then here I'm going to get, open brackets, integral of sine phi minus 0 to pi, then minus here, I'll tackle this alone, tackle this part alone. So if I'm to tackle this part alone, what am I getting? Here we can use a substitution. If you have cos squared phi, I can let's say u to be equal to cos phi, then the u over the phi will give me sine phi. That is negative sine phi, right? So at this point, I can make the phi the subject, and that is going to give me, the phi will simply give me 1 over what? Negative sine phi. And when I introduce it here, the 1 over negative sine phi here, multiplying sine phi, then here will be what? U squared, and I'll have the u here. This is a little substitution and a recap from calculus 2, so don't get confused. So once I get this here, this will cancel this. Then finally I can have u. So if I integrate u, I'll get u cubed over what? 3. Therefore, this here, when I integrate this, I'm going to get negative what? Cos phi 0 pi minus here. This will give me u cubed over 3, where my u is what? Cos theta. Sorry, cos phi. So cos phi cubed over 3. Then I had a negative here, so this happens to be what? Positive. So once I get this, I'll introduce 0 to what? Pi also here. Now what is cos 0 is 1, then what is cos pi? So if I put this into my integral, negative cos, you're going to get 0 to, so let me change, so integral negative cos of x 0 to 180. So this part alone is going to give me 0 plus this side. Sorry, this will not give me 0. So if I have this, I'll just put negative out cos 180, which is negative 1, then minus, I have 0 here. So cos 0 will give me 1, and that is going to give me, this is negative 2, so minus 2, then 2, I'll get 2 there, then plus, when I come here, I'm going to get cos cube, so cos 180 cube, so cos cube, so cos to the power 3 of 180, that is 1 over 3, then minus, when I put 0, I'll get 1, so 1 over 3. So at this point I'm getting pi here, so Here will be 0, then here is 2. So I'll multiply this and I'm going to get 6415 pi. Okay, so from here you realize that this is just the computation from calculus 2. So just take your time and you go through, but the most necessary part is you finding your limit point here, as well as you going by drawing the diagram and understanding how to go by it. Thanks for watching, and don't forget to subscribe, like and share.